We had a request to do test 3 from this semester, a good hydroboration mechanism. So on your final, there'll be a label, and it'll say hydroboration oxidation. So that would be there, hopefully trying to jog your memory. And you better do hydroboration first, where the pi attacks the less electronegative B. H takes its electrons and goes to the more substituted carbon. You're making both bonds at the same time, so it's thin. Thin with a new H here and a new B here. And, you know, I don't like writing SIA. R equals SIA. R2. Look at that. It's just easier. Okay? You can do that. It looks like a Q, though, or a G. Sig. Oh, big eraser. We need our little eraser. Still the big eraser. Okay. Hydroboration's over. Now you want to do numbering 6 steps and then tautomerization. I'm going to number my steps now because I know there's 6 steps. There's some patterns. We got to get it right. Acid base, step 1, step 6. We're on step 1. Acid base. Base is OH. Lone pair, please. Grabs H from peroxide, hydrogen peroxide. It makes a peroxide anion. We'll do these in baby blue with numbers. 1. When you make OOH, you better use it. When you make O minus, you got to attack which atom? The first 2 times you make O minus. This is time number 1. What atom do you attack with it in the next step? Both times. B. Step 2, we attack the B. You got your iso, you got your double, and you got your B. Your 2 R groups didn't leave, never will. You got to draw the OO bond. And what about boron? It has 4 bonds now. 4 minus. Step 3 is the interesting one, where the O sees a way of getting away from being bonded to O, and we generate a more stable O minus instead of a B minus. It's got a lot going for it, this rearrangement step. Okay, now that bond is now up to here where there's an O. I know it looks extreme, but just trying to show that the only thing that happened was we moved that carbon to the O. And equally important, you made a new O minus. What are you going to do with the O minus? Attack the B again. And let's see, if I go one more to the right, I think I'll be okay. Maybe upright. You got your iso C-double-C bonded to an O. It's got a B, 2 R groups, and a new O. That's 4 bonds to B. Last time B is going to be minus. Step 5, you got to get the other O off. Remember, step 4, you put one O on. Step 5, get the other O off. The other O is the one attached to carbon. It gets its electrons because O loves electrons. The hog. An electronegative hog. O minus and H. Show the bond from H to O, people, because acid base is next. Better have some kind of proton with its bond showing. Step 6, acid base. Lone pair grabs H. Sigma becomes lone pair. You made the isopropyl attached to a C double C attached to an O that has an H. And the other product was this guy right here, if you're curious. Right? OB with 2 R groups. What's this last step called? I'm not going to number it. It's a tautomerization. You're going to need an acid-base conjugate pair. Which is the only appropriate acid-base conjugate pair in this whole question? Do you see any acids or bases on step 2? Because you can use as much of the base that you have there as you want. OH minus is the base. What is the conjugate acid of OH minus? Because you need that as well. Water. Put the water near the pi, please. Because the pi is going to pick up a proton. This is tautomerization, where you grab an H. Sigma becomes pi. The old pi picks up a proton. Look at the flow of electrons. It all flows in one direction. That's how electrons flow. That's tautomerization. Looks a lot like elimination. I hope you're seeing that. And I just put a T there. T for tautomerization. You don't need those labels really for points. And that, I'm going to not do B for one reason. I don't have any circling and explaining on the final. Can you please forgive me if there's one circling without an explaining? Because I think there might be. And like, I'll give you 2 products and ask you to choose which one. That's the extent of the circling you're going to get. There's no explaining in the short in the mechanism section. And that's a relief to a lot of you, because I know we don't love explaining. Okay? And that's it.